Okay, if you were gone on Friday, okay, let's review for those people. What does an integral stand for? Okay, it's an antiderivative, but if it's on a certain interval, what would you do to the graph? You would find the what? Oh, he's not here actually. Sorry. Thank you. Okay, you would find that it starts with an A, ends in area. No? Nobody? Okay, the area between f of x and the x-axis on A to B. You remember that? No? Okay, so if I had a graph, let's just say here's my graph. Do you need it, Marcel? I'll get it for you. Were you here Friday?
No.
It's okay, I'll give you another one.
Okay.
I love to give notes to people, so there you go. Okay, here's A.
Are we going to need the space?
If I can fit it, you can probably fit it. So I would say you're probably fine. Okay, if I integrate from A to B, that represents the exact amount of area in this little section of the graph. Now, remember that on Friday, we were only looking at things that were geometric so that you could use your geometry formulas, circles, triangles, trapezoids, etc. Okay? So what we're going to look at today is properties of integrals. So I want you to think about the area thing. What would the integral from A to A be? 0. Why? That's correct. Because you're starting at A and then you're shading until A. You didn't shade anything, yeah? So this would be 0. Okay, and I'm going to put a little star here because there's no area on A to A. That's not really an interval. It's too skinny to have any area between it, okay? Okay, look at number 2. What is different about the integral presented here and the integral in number 2? Okay, it is backwards. Okay, so notice that for this one, it's backwards. And so instead of integrating from A to B, you'll notice that it's from B to A. That means that it's negative integral A to B of f of x. So if the endpoints are backwards, you're going to change the sign. If the integral is already negative, when you switch it, it'll be positive. If it was positive, it'll switch to be negative. Okay, the next one. On your graph that you drew here, I want you to put a C out here to the side. Let's say that I wanted to integrate all the way from A until C. What you would do is integrate from A to B, and then you would pick back up at B and continue shading until C. Would that give you the same amount of area if you added the orange and the green areas? Yes. So this integral from A to C, you would break up A to B of f of x. It's just showing that you can break it up. And you'll see why when we get down to this next section. So basically, if you have two integrals that are next to each other, you can just integrate straight through. Okay? Next one, if you have k, that's a constant, then you are allowed to take that constant to the outside and then just multiply it by the integral at the end. So if you have a constant inside the integral, you can find the area and then just multiply by the constant afterwards. Okay, and then the last one, if you have two functions, f and g, and you want to integrate their sum, then just like limits, you're allowed to separate them into separate integrals and then add the answers together. So this is what that would look like. And then real quick, so these aren't backwards, so you make it a to b instead of b to a. So the way that you could separate that would be a to b of f of x plus a to b of g of x. So if you have one big integral, then you're allowed to split it up to where f and g are on their own. Okay? So we're going to use all of those rules on the next two problem sets. The first one, you're just given stuff. So this one says the integral from 1 to 4 is -2. Integral from 4 to 8 is 6. Integral from 1 to 8 of g of x is 10. Okay, look at letter A. I want the integral from 1 to 1. What will it be? Okay, which rule is that? 1, 2, 3, 4, 5. Rule number 1. If your endpoints are the same, then your integral is automatically 0. Make sense? Okay. Letter B, I want the integral from 1 to 8. Now, Sean, this is the question that you had asked. Okay, if I want 1 to 8, but I have these separately, then I would be using that rule that we talked about where you can split them up. So 1 to 8 is the same as 1 to 4 of f of x plus 4 to 8 f of x. So if I want to go straight from 1 to 8, that is the same as if I go 1 to 4, stop, and then keep going 4 to 8. So what's the integral from 1 to 4? -2. What's the integral from 4 to 8? 6. So what's -2 plus 6? 4 left over. Very good. Now, real quick, let's talk about why is this first integral negative? Where must the area be? Well, not on the left, but below. Yeah? So just remember, if an integral is negative, that means your area was below. Okay, then my next one, I want letter C. I want the integral from 1 to 8 of f plus g. That's the same as the integral from 1 to 8 of f of x plus the integral from 1 to 8 of g of x. What's the integral from 1 to 8 of f? Thank you. We just found it in part B. What was that first integral? Okay, 4, right? And then what's the second integral? 10. So if I do 4 plus 10, that's how many? 14. So 4 plus 10, 14. Okay? Let's skip down, please, to letter F right here. If the integral from 1 to 8 is 14, what will the integral be from 8 to 1? -14. Do we understand why? Okay, I'm going to put here this equals the negative integral from 1 to 8 of g of x plus f of x. And so then if this one is 14, this is supposed to be a negative here in the front. Okay, it's negative because the endpoints were backwards. Okay? So it's negative because the endpoints were backwards. Okay, 2 more left. Do letter E real quick. If I want the integral from 8 to 1 of f of x, what would that equal? -4. Because why? Why is it -4? Endpoints are backwards. Okay, and then for letter D, I want the integral of 2 f of x. Well, then I can take my 2 to the outside. 2 integral 4 to 1 of f of x. And then I have one more rule that I have to use. After I remove the 2, I notice that my endpoints are what? backwards. So I'm going to make it a -2 in the front, and I'm going to fix my endpoints. So I brought the 2 to the front, and then because these were backwards, I had to switch them, which put a negative out here in the front because I changed the order. Okay, then what is the integral for f of x from 1 to 4 was given to you? So I have -2 times -2 again. That comes out to be what? 4. Make sense? Okay. Next one. Look at this next little section. Okay, so you have a graph of f of x here. Okay, go ahead and change letter B. It says a G. It should be an F. Okay, part A. I want the integral from 2 to 2 of f of x. What will it be? 0. Why? Because you have the same endpoint. You don't actually have any area accumulated if you start and stop at 2. Okay, letter B. I want to go from -2 to 2. Shade on your graph what shape that is. This is what we did Friday. So -2 is here. 2 is here. So if I shade that, what shape is that? Okay, half of a circle. So how do I find the area of a whole circle? It'd be pi r squared. And then what's my r? Okay, good. From here to here is 2. But then I only want half of it. So 2 squared is 4. So it's really 4 pi. But then only half of 4 pi would be 2 pi. Now, question. Should my 2 pi be positive or negative? Positive because it's where? Above. Very good. Okay, go to letter C. Now I want to integrate from 2 to -2. How is that different? It should be -2 pi. Because why? What were your endpoints? They were backwards. Very good. Okay? Now, if you want to do, in this example we did up here, how we rewrote everything to show the properties, that's fine, but it's not necessary. As long as you know what you're doing, you don't have to flip it and put the negative in the front. That's fine. Okay, go down to letter D. I want to go from -7 to -2. Is that forward or backwards? -7 to -2. Is it forward or backwards? It's forward. Okay, because where's -7? It's on the left, and then I'm going forward to -2. So if you're shading to the right, that counts as forward. Okay, so what shape is that? Triangle. Okay, find the base and the height. Now remember, my base only runs from here to here. So is my base 7? No, how far is it? 5. So my base here is 5. So it's 1/2 5 times, what's my height? 1. So 5 times 1 is 5. Cut it in half is 5/2. Now, will this integral equal positive 5/2 because it's forward? No, it will still be negative because where's the area?
Below.
Very good. Area is below. So there are 2 ways now that your integral can come out negative. If the area is below or if the area was backwards on the integral. Okay, go to letter E. From -7 to 0, that's forward. From -7 to -2, how much area would I have gotten? -5/2. But then from -2 to 0, if I keep going, how much of the circle do I want? The entire 2 pi? Only half of it, so it would just be pi. So on that graph, I'm going to shade it here, but look, you would have shaded all of the triangle and then only part of the semicircle. So that's why we would be using only a pi instead of a 2 pi. Okay? Alright, go to letter F. How is letter F different than letter D? What are the endpoints? Backwards. So if the original one was negative 5 over 2, what is letter F going to be? Positive 5 over 2. Now let's talk about something for this part of the graph. If I look at it, my 5 over 2, it's below, so it's negative. So then if I apply a backwards as well, it's a double negative, they cancel out. Yeah, so it's negative because it's backwards, negative because it's below, then they cross out, now it's positive. Okay, alright, do that last G, and then you can cross out the plus 2 here, you don't need that. Okay, so I pull that 2 out to the front. From 2 to 5, what shape am I highlighting? Okay, the triangle on top, and you see the little baby triangle on bottom? So you're going to have to find the areas for both of those. Okay? So find the area of the top one and the bottom one, because that's going to include both. So if I was doing this one, what is my base?
3.
Almost 3. It's actually 2.5. So I'm going to make that 2.5. Okay, because see how it crosses right between 4 and 5? Okay, and then what's my height here? 3. So if I wanted the area of that triangle, it would be 1/2. My base is 5/2. My height is 3. I was going to do it as a decimal, but then if I have to cut it in half, I don't want to. So it'd be 1/2 of 5/2 times 3, which is how much? Just keep it as a fraction. But keep the 3. What's 3 times 5 on top? 15/4. Very good. Okay, now let's do my little baby triangle on the bottom. 1/2. What's my base? From here to here. That's 1/2. And then what's my height on that little baby triangle? 1. So I have 1/2 times 1. That's really 1/4. Now, when I set up my integral down here, am I going to add 15/4 and 1/4? No. Why am I going to subtract? Because this one's on top, this one's on bottom, so I actually need to subtract. So I'm going to put here, this is going to be 2 times 15/4 positive minus 1/4 negative. And what is 15/4 minus 1/4? 14/4. And can that reduce if it's 14/4? That's really 7 over 2. And if it's 2 times 7 over 2, then how much is that really? It'd just be 7. Because I can let the 2's cross out with each other. Okay? But if it was free response, you could have left it like this and you would have gotten full credit. Okay? Alright, last 2. Look at letter H. I want to go only from 2 to 5 of f of x. Okay, we just did that. What is different about this one and this one? This one has a 2 in the front, right? So if I take the 2 away, how much was just the area part? It would just be 7 over 2. Very good. Okay, you would just remove the times 2, basically. Okay, and then letter I, the integral from 4 to 5. That's my little baby triangle. Actually, hold on. From 4 to 5 would be here. What do you notice? Okay, if I start here at 4, and then I shade till 5, what's going to happen with my triangles? They're going to cancel out. Why? Because the one on top and the one on bottom are the exact same size. So they're going to cross out to be 0. Okay? Good? Alright, look at your homework. I want you to do problem 1. There's like a B, C, D, E, F. Okay? So So you're looking at homework 3, and you're going to just do number 1. Now notice the areas are marked for you since they're not perfect shapes. So that one's 1.2, 3.7, and then 0.8. That's for each of those areas. And then that one's 3.2, and then that one's 2.7. Okay? So look at that first one. If I want the integral from a to c of f of x, that's my first graph. A to c, how much area did I get? 1.2, positive or negative? Positive because it's above. Okay, what about if I went from a to c on graph g of x? That's this one. It'd be what? 3.2. Also positive, right? Then for letter C, if I want to go from A to C of f plus g, then remember, I'm allowed to find the areas separately and then just add them. So if this one's 1.2, and this one is 3.2, oops, then I'm just going to add those. How much would I get? 4 point what? 4.4. Oh. Okay, now see if you can do that last row. Okay, do your last 3, D, E, F. Okay, so if you're a little bit lost for letter D, you're going to go A to E of F. What are you going to do with 1.2 and 3.7? You're going to do 1.2 minus 3.7, and then what about the 0.8? Add 0.8. Very good. Look at Marcel. Okay. So 1.2 and 0.8 add to 2. But then I have to minus the 3.7. What's my net area in this graph? Negative 1.7. Okay, now look at your G graph. What are you going to do with 3.2 and 2.7? Subtract. And what is 3.2 minus 2.7? 0.5. And so then I'll have negative 1.2 plus 0.5, what is it? Negative 0.7, right?
No, it's negative 1.7 plus 0.5 equals 0.2. It's negative 1.7 plus.
Yeah.
But you want some negative 1.2.
Oh, what?
You want the answer. You want the answer instead of negative 1.2.
Oh, I wrote the wrong number here. I was like, come on, people, I can add. Okay. Crap, this is a 7, thanks. Look, so creative. Okay, and now if I do negative 1.7, then it's negative. Okay, fine, you're right. Good. Okay, what about skip to letter F? What if I wanted to do E to A of those functions added? Instead of negative 1.2, it would be positive 1.2, because it's just backwards of the integral that we just did. Okay, and then for letter E, remember that you're allowed to take the 3 to the front, you're allowed to take the 2 to the front. So it would look like this if you broke it up. 3 integral A to E of f of x plus 2 integral A to E of g of x. Now, rewriting it is not necessary if you already know how to do it, okay? But just to show you what rules you're doing, that's why I'm rewriting it. Okay, so then it would be 3 times negative 1.7 plus 2 times 0.5. And then if you do 3 times negative 1.7, that would be negative 5.1. And then 2 times 0.5 is 1. So negative 5.1 plus 1 is negative 4.1. Good. Got it? Okay, last one I'm going to make you do off the homework before we move on. Okay, is the very last one. So go to number 15. Okay, I'm going to give you a minute to look at it, and then I want you to do part A.
Number 6.
15. This one right here. Huh? Yeah. So you're doing this one right here, yeah? Oh, the whole answer key?
15.
Oh. So 0, negative 2, 0, 3, 0. That one should have been 4. And then that one should have been 2.
Having a family dinner tonight. Because we haven't eaten together as well.
And then you're only going to negative 3. So it would be that little triangle. So it's 2
Oh, I
wide.
added the other triangle. That's why. Okay.
We did those last time. You're just setting up. So when it says set up the integral, you'd say like integral negative 4 to 4 of f of x, and then you'd find the area. So that one's a triangle. You just put 16. So you don't have to actually find it. You're just saying like where are you integrating this one 0 to 5 of f of x, and then you'd find the two areas and subtract.
Okay, I didn't know. Yeah, I didn't know if I was supposed to write like.
Yeah, some people were actually finding them. That's kind of a waste of time. Though. You don't have to do all that. Okay, let's look at letter A. Does anybody get it? Okay, this one's set up kind of tricky. Okay, but when you look at your function, it's up here. And then it says that a of t is the integral from negative 3 to t. This is what that means. When you plug numbers in, a of a number, it's going to be the integral from negative 3 till that number of f of x. So what is the lower boundary always? Negative 3. What's the number that you're changing? This one. So for example, if I'm doing letter A here, a of negative 3 is the integral from negative 3 to negative 3. Now you know it's 0. That's correct. Okay, now I'm going to help you with B, and then I'm going to give you time to finish. Okay, so if I want a of negative 1, that's the integral from where? Negative 3 till negative 1. So they're not giving you an option for the bottom part, but they're having you change the top part. So now looking at my graph, negative 3 is negative 1, 2, 3 is here. And then I'm going to shade all the way until negative 1, which is here. And then you would break that down into what shape? Triangle. So it would be 1/2 base times height. How long is my base? 2. How tall is my height? 2. So that would be 1/2 2 times 2, which is half of 4, which is 2. And it would be negative 2 for the integral, because the area was below. Okay, can you finish it now? Okay, so now try again. And then watch out for the ones that are backwards. Okay, what'd y'all get for letter C? It is 0. Okay, because from -3 to -1 you get a triangle, and then from -1 to 1 you get an equal triangle. So those are going to cancel out with each other. Okay, then from -3 till 3, what would you be finding the area of? Okay, this is a trapezoid right here. Now, technically, do you care about these two triangles? They canceled each other out anyway, so nobody cares. What is the area of that trapezoid right here? I think it's 3. Okay, so look, you would have done 1/2. How tall is this, or how wide is this top base? 1. How long is the bottom base? 1 plus 2, and then how tall is it? 2. Oops. So 1 plus 2 is 3, times 2 is 6, cut it in half is 3. So the area on that one would have just been 3. Okay, bottom row, -3 till 5. How does that come out? It is 0, because what happens when I continue to shade on my graph? Look at this next trapezoid. It's also how big? The same. So these two triangles cross out, then these two trapezoids cross out, then your answer is 0. Okay, -3 to -5. I'm starting here at -3, I'm going back to -5. What shape did I highlight? Okay, rectangle, what's its area? 4. Because it's 2 across and then 2 down. Okay, but then is it positive or -4?
Well, it's positive because it goes backwards.
It's positive because it's below negative and it's backwards below. Or I didn't say that right, but you get the idea. Okay, it's negative and it's backwards. Those cross out with each other. Okay, then last one, -3 to -4. Okay, -3 to -4 would be here. And so that would be how much of the rectangle? Instead of all 4, you would just want 2. Good? Easy. Okay. Great. All right, we don't really have time to start your notes. So if, your notes for Wednesday. So I don't see you tomorrow. This is not due till Friday. And have fun with whatever fun is in store for you. No, I don't think y'all have late start. Yeah, and if you're taking the English AP test class, then you have to take your mock exam again. Yes.
So much.